Okay, in this section we'll talk a little bit about press work. And not every small lab or shop has a press, but if you have a press, there's a lot of useful things you can do with it. Now, the first thing you have to know about presses, that they have deceiving looks, because it's one of the most dangerous machines in a shop. Now, the reason why a press is such a dangerous machine, that if you compress a piece of steel, it stores up a lot of energy. If this is a brittle material, it can suddenly shatter, and all this energy is released at once. Now, everybody can imagine if you take a big truck spring and bend it in two, when it snaps open, it can kill a person. But you don't think of it that if you take a block of steel, which has the same weight as a truck spring, and you compress it to near its strength limit, it stores up more energy than a bent over truck spring, because truck spring is not stressed to the limit. So if you take a piece of steel, same weight, compress it here, say with 100 tons, and it shatters, it will release an energy much more than a cartridge from a rifle, okay? And certainly can kill a person instantly. And you have to remember, when a piece of steel shatters, because of the Poisson ratio, the forces are not just up and down, the forces are also sideways. It shatters and pieces fly like shrapnel in all directions. So the first rule of a press is never press a hardened piece or a brittle piece, because it will store up all the energy, and if it shatters, it will just fly like a shrapnel, like a hand grenade. Even if you compress ductile materials, sometimes you're using tooling, and the tooling may be a bit hardened. So there's always a risk. The press itself is hardened. So the best thing you can do, if you have any doubts at all, is provide a shield like this made of half-inch polycarbonate, because the polycarbonate is shatterproof. Okay? So anything except pressing sheet metal should really be done with a shield in place. That's very, very important. The second thing which is very important to know about a press is that if you take a very little piece, like a dime, and put it in and put the full force on, it will damage the press. Because the reason is you'll have the 100 tons all concentrated on the area of a dime. Even if the dime will expand a bit, you have 100 tons, say, concentrated on maybe 2 square centimeters, which by far exceeds the yield strength of the best steel. Because you're going to get 50 tons per square centimeter, and most steels will yield at about 20 tons or 10 tons per square centimeter, so it will make a dent in the press. So even a washer made of aluminum, if you put it in the press and you press it to the limit of the force, will damage the press. So you always have to think that if this press is 100 ton, and this is made of steel, and to take a safety factor should not be loaded more than, say, 10 tons per square centimeter, you cannot apply the full force, or you shouldn't actually press something with an area less than 10 square centimeters. Otherwise, if by mistake you applied more force, it will dent the press and can even crack it. Okay, so it's kind of a very unintuitive thing, that even if you put in a piece of plastic, okay, piece of wood, which is very small, and you compress it, you'll damage the press. So these are the two things people don't think about, but I want to emphasize again, the real danger here, if absent-mindedly you put in a piece of hardened steel, okay, and you compress it, it's guaranteed to shatter, and it's just a matter of luck if the shrapnel will kill you or not. Okay, so you should be well aware of it. Okay, so what is a press good for? A press by itself is mainly good for straightening and flattening and things like this, but a press in conjunction with a water jet is a great combination, because if you have a water jet next to it, you can cut the tooling. So if you need special shapes, in minutes you can cut the tooling on the water jet from a plate of mild steel, and then put it in the press and press these shapes out in sheet metal. Now this is especially important if you're wanting to make very high performance structures, like you want to make some airborne things, if you want to make lightweight, very high performance lightweight structures, then the best way to get stiffness in lightweight structures is to use closed form pieces, the same way as a car gets its rigidity. So basically, if I take 2 strips of metal, or 1 strip the thickness of 2, and I just keep it flat, I can easily bend it. There's basically no rigidity and no strength. Okay? I can basically bend it. But if I press in a rib, okay, then immediately the moment of inertia goes up, of course, and then the strength goes up. But the best thing is closed form, because if I just bend it up like this, without a press, it's also very strong this way, but it's not strong torsionally. I can still twist it. But to get it strong torsionally, you need a closed shape. So if you press in with a press 2 ribs, okay, and then spot weld around the edge, you end up with something which has exactly the same weight, okay, but it's stiff in bending, it's stiff torsionally. Okay, so if you're really concerned about lightweight, strong structures, you probably need to use presses somewhere, press in ribs, okay? And the material could be either stainless, could be mild steel, but if you really need high performance structures, the best material to use is some stainless steels which can be heat treated after forming. So if you look at something like 17.7 stainless or some other alloys like this, which can be hardened just by heat treating cycles, they don't need quenching. So what you do is you press it out in the annealed form, spot weld and finish, and then you put the whole thing in the oven through the temperature cycle, and then it comes out with a very high elastic range. So even if you bend it, it will spring back. Okay? So for normal structures, steel is the best. This is powder coated. But for really high performance structures, some of the stainless steels, which are annealed and get hardened with a simple heat treatment cycle, are the best. For example, this is a lightweight box, so it needed some reinforcement on the cover. So you cut on the water jet 2 layers. One layer, which is the X with these tabs, and the other layer is just the back. Spot weld them together, and then you just put a piece of metal over it and press the shape, which I'll show you in a minute. Now this is still much faster than going on a CNC mill and milling out this pattern. Because the main thing is when you mill it, you have to find a way to clamp it, and you have to worry about a lot of things. With a water jet, you just cut the 2 pieces, spot weld them together, and you're done in 5 minutes. Now, another example where you need a press is if you want to make cylindrical boxes. Because usually, if you want to make like some drum or any kind of cylinder, you need round covers at the ends. And the round covers, they have to have a lip bent up so you can spot weld around it. And the way you do that is you make yourself a set of tooling like this. The beauty of the water jet, it gives you male and female at the same time, but you have to have a bit more clearance than you think. So let's say if the material is 1 millimeter thick, the clearance should be about 1.5 or 2 all around. Because if you make it with no clearance, it will jam together, you won't be able to get it out again. Okay? So here you'll put the sheet metal over it, and which I'll show you immediately the steps, and then you press it, and then it comes out with ugly edges, so you just sand the edges to get a nice disc, which we'll do later. So I want to show you exactly how to do it, because a big trick in pressing, if you have a male and female, is how do you line them up? Because you have a sheet metal in between. Say, if I want to press out a cup, and if I misplace this a little bit, I'll just ruin everything, ruin the tool and ruin the job. So the trick is how to align it. So I want to show you how this is done. So as an exercise, we have a piece of thin steel, about 0.5 millimeter, and we want to stiffen it by some ribs. And we decided we want a rib to go all around. Okay? So the way you do that, you can press in 2 methods. One method is press just with a male tool against rubber, and the rubber will push it in, or if you want to push it in very well, you do it against lead. And the other way to do it is a male and female. Okay? So we'll do both ways, and you also see the difference. So the first way is I just go on the water jet, cut out the shape of the rib I want, okay? Back it up with some material that's a little bit too small. with this hard rubber. It has to be very hard rubber or very hard polyurethane, which is the best. Okay, but even this is a little bit too small, but anyway, that's what we have. Okay, so you line it up, and all what you have to, and then now it doesn't matter, there's no alignment, you just press up all the material. Okay, and you put it in. It's important to put it in the middle of the press, because you don't want to try to bend the press. Put it in the middle of the press. Because it's sheet metal, you can get away without the guard. Okay, so, and let's see, everything is correct, yeah. And you give it the full 100 tons. Okay, so what this does, it presses a nice rib, but it doesn't have such sharp definition. So most of the time that's enough. Here it actually snaps. One reason it snaps because the rubber was too small. It didn't cover the edges, so the edges wrinkled. The rubber has to be bigger than the metal. But anyway, it doesn't have such high definition, although this may be sufficient for a shape. But now you can press them with male and female, because now you already have something which will register the two halves. So now what you do is you put this down. Okay, let's try to make it snap less. Okay, so now you can put this down. You can put down the male on the inside, that's going to be registered, and you can put down the female on the other side too. So you put it like this to make sure it really sits in the groove. Okay, and then you put this on it, like this. Okay, and now you know that it's going to be registered. Okay, and if it was anything other than sheet metal, I would have closed the guard. Give it a full 100 tons. Okay, the difference is that now I'm getting much sharper lines, because now it has a male and female, and also now you can do a deep draw if you wanted to raise it like a whole centimeter. Now, if you want to do any deep draw, it has to be annealed, meaning get it red hot and let it cool down. Now, if you want to do a real complex shape, you may have to do a double draw. For example, if this had to be very deep drawn, you'll draw it first, say, with a 1/2 inch thick, which you can still draw in one draw, and then anneal it, and then draw it with a 1 inch thick die. Because if you try to pull it down in 1 inch at one time, it'll tear. Just like it's done in industry, where depending on the ductility of the material, you sometimes need to anneal in between. Okay, but you can press very nice shapes like this, and as you see, the tooling is very simple. So if I wanted to do this, if I wanted to press a circle in this, I would have done the same. I would have pressed it first against rubber in order to get a rough shape, and then this rough shape will allow me to align the male and the female, and then press an accurate shape. So as I said, if you want to press it in one step with sharp detail, you have to press it into lead, and the lead, of course, can be reused by melting it again. So if I wanted to press this shape into this, I will just put a sheet of lead, maybe 1/2 inch thick, under it. Now you have to be a bit careful, because if this is steel and has sharp corners, these corners are not rounded, it may actually shear, because there's no big difference between a shear and a press. If I wanted to shear it out, I would make this part hardened with sharp corners. I would press it into rubber or lead and actually punch out the part, which is also useful if you want many, many parts and you just punch them out. So right now this is actually, the corners are pretty sharp, so I'm not sure what it will do, whether it will press or shear, but we can see. Okay, I put it in, try to center it. Okay, so yeah, now it pressed it. So you can see it pressed it out, and with not bad definition. I could have pressed it a little bit more because it's still a rounded edge. At some point the area is just too big. But you also notice something interesting, because I didn't round the edges. It was on the borderline between pressing and shearing, and you can see at one end it sheared. See, if you look at this end, it actually sheared because one end was sharper than others. All the other tooling here have a rounded edge. So you can see you can use it as a very nice precise shear if this was hardened.